Hello guys, how are you? Welcome to GeoMind. In this video, we will start the Carboniferous period. This video is the part of the geological timescale video series that I have been doing. I've already made the videos on Cambrian period till Devonian period and also on the Precambrian history of Earth. So if you want, you can check them later. I will provide the link at the end of the video. Okay, so without further wasting time, let's start. So first of all, I would like to describe this thumbnail which I put on my video. So you can see there is extensive forest in the background. These are some reptiles or tetrapods, you can say. Okay, this is insect and arthropod. Okay, a centipede type of organism, and we will talk about these later in the videos. Okay, maybe in the second part of the videos when we are talking about the fossils of Carboniferous period. This you can see is a dragonfly. Its name was Meganura, and it's one of the largest creature insects you can say. It was around 70 centimeter in length. That's about 2 feet. Okay, so we will talk about them in the second part of the video, hopefully. Okay, so that's it. And these are the amphibians. So the Carboniferous period is also known as the age of the amphibians. So let's start. So from now onwards, I would include two daily questions in my video. So you have to comment down in the box the answers of these two questions. So first question is, which one is the longest period of the Phanerozoic eon? Cretaceous, Carboniferous, Cambrian, Jurassic. So out of these four, you have to answer the correct. Okay, you have to answer the correct one down in the comment box. In the second questions, the Cambrian period is named after what? Okay, after the Cambria Mountains, after a Roman name of Wales, that is in UK, Cambrian Formation, invertebrate fossil name Cambria. So, if you know these questions, please comment down in the box. Now, first of all, uh, I would like to take you to the geological time scale. Okay, and here you can see the Carboniferous sits between the Permian and the Devonian period. Okay, in the Paleozoic era, in the Phanerozoic eon. So under the Carboniferous, there are two major series, that is Mississippian and Pennsylvanian. Okay, and the boundary between the Mississippian and Pennsylvanian is 318 million years. Okay, and the Carboniferous itself spans from 359 or 360 million years to 299 or 300 million years. Okay, so that's very huge timeline. So let's start with the more detailed chart of the geological time of Carboniferous. So in this you can see the Mississippian and the Pennsylvanian series. Okay, and these are the stages. So the lower stages, Tunasian, okay, then is Visian, and these is nail-like structure you see here are the GSSPs. Uh, about the GSSP, I've already talked about the GSSP in the previous videos, okay, and the GSSP of the lower Carboniferous or the Carboniferous boundary, okay, the Devonian Carboniferous boundary is marked by the conodont Siphonodella sulcata, okay, so it's in France, the locality is in France. Now let's talk about some basic facts of Carboniferous period. So Carboniferous is the fifth interval of Paleozoic era. Okay, so it comes after the Devonian period and precedes the Permian period. Okay, time span is 359 to 299 million years. It's the longest period of Paleozoic era, and it's the second longest of Phanerozoic eon. The name Carboniferous refers to the coal-bearing strata So it was named by English geologist William Conybeare and William Phillips in 1822. It is also referred as the age of amphibians. So amphibians diversified in the previous videos. Okay, in the Devonian video, I have talked about the evolution of fish. Okay, and how the tetrapod came into the existence from the evolution of lobed fin fishes. So if you want, you can check that video later. Okay, and the most significant part was the high level of oxygen. The oxygen was about 35%. Okay, there was a significant jump of oxygen from Devonian period to Carboniferous period. So in Devonian period, you can see the oxygen was about 15%, 15 to 16%, and there was almost 20% jump in the oxygen levels. Okay, so we will talk about this later, that why there was high oxygen. Well, obviously the main reason was the extensive forest and the lack of microbes at that time. Okay, so next one is Appalachian orogeny, or it's also known as Alleghanian orogeny. Okay, in the when we are talking about the North America, Hercynian or Variscan orogeny when we are talking about the Europe. Okay, so when I am going back and forth between the Hercynian or Variscan, you have to remember that Hercynian and Variscan uh, are same, and Appalachian and Alleghanian are same. Okay, now so the two major subdivisions of Carboniferous are Mississippian and Pennsylvanian. Okay, and in Europe, the Carboniferous period is subdivided into Dinacian and succeeding Silesian. Okay, so when we are talking about Mississippian and Pennsylvanian, it's mainly we are talking about the Northern America, that is USA, okay, or Canada. The minor extinction event is the Carboniferous rainforest collapse. We will talk about this in the later part of the videos. Okay, so this was some overview about the Carboniferous period. So let's talk about what Earth looked like in the Carboniferous. So this is the late Carboniferous. Okay, so you can see this is Panthalassa Ocean. This is our Pangaea. Pangaea was starting to form. So uh, first let's talk about the early Carboniferous. So I will take you back to the late Carboniferous. So in early Carboniferous, we have seen in the Devonian period that how Euro-America was formed, and here was Gondwana. This is the Paleolithian Sea. The yellow line you see are the subduction zones. This is the Kazakhstan. It was independently floating. Then was the Siberia independent. North China was independent. Okay. And the Australia, Antarctica, India, Arabia, South America was all part of the Gondwana supercontinent. Now, the early Carboniferous, the Earth looked something like this. So there was a gap between Euro-America and Gondwana. And then the Gondwana started to shift towards the Euro-America, and Euro-America shifted towards the Gondwana. So this Paleolithic ocean between started to shut down. So in the later part, the Pangaea started to form, and this is Alleghanian and or Appalachian orogeny, or Hercynian or Variscan orogeny. Okay, this is the another image of the late part of the uh, Carboniferous period. So the Appalachian Mountains were here when the Gondwana and Pangaea collided. Sorry, Gondwana and Euro-America collided, and the Pangaea started to form. Okay, so this was the start of the Pangaea. So Siberia was still floating, Kazakhstan was still floating. So later Siberia will join the Pangaea, and the whole Pangaea will be complete in the Permian period. Okay, so these are the Ural Mountains which formed after the when Kazakhstan will collide with the Pangaea. Okay, so we'll talk about this in detail. Now, talking about the paleogeography. So early Carboniferous, that is Mississippian. Uh, so Euro-America was in northern hemisphere in the early Carboniferous, while Gondwana was in south. We have already seen, and cratons of Siberia, Kazakhstan, and China were separate, occupying high latitudes. Okay, so you can see in this image, these are the high latitudes. Okay, and Euro-America was separate. Gondwana was in southern hemisphere, and the glaciation was there. So Euro-America is also known as Old Red Sandstone Continent. During early Carboniferous, Paleotithyan Ocean began to close, forming Appalachian and Variscan mountains. So you can see in early Carboniferous, this Paleotithyan Ocean started to close as this started to shift. Okay, these two started to shift towards each other. So assembly of Pangaea was complete by the middle of the Permian period and following Uralian orogeny. So when Urals mountains formed, then you can say the Pangaea was complete. Okay, so when Siberia fused with Pangaea, so you can see this portion will fuse with Pangaea during the Permian time. Okay, so when we make the video of Permian, you will see the complete Pangaea here. Now so by the late Carboniferous, around 300 million year approx, Laurasia came into contact with Gondwana and closed the Tethyan Sea. Laurasia, and beware, Laurasia is also known as Euro-America. So don't be confused when I'm talking about the Laurasia. Okay, so Laurasia and Gondwana were fused by the Appalachian and Hercynian orogeny, which continued in the Permian period. China and Siberia continued to reside at the high latitude. Okay, Ural orogeny started at the end of Carboniferous. So this is a graphic of how Pangaea formed. So you can see in the late Devonian there was an microcontinent named as Avalonia, and Avalonia collided with the Euro-America. Okay, sorry, Laurentia, and Euro-America formed. Then in the Mississippian, the formation of supercontinent Pangaea started to begin, and early Alleghenian, or you can say Appalachian orogeny started, and the late Pennsylvanian, okay, fold belt started to form, climax of Appalachian orogeny. Okay, so Appalachian orogeny were complete during the late Pennsylvanian, and in the late Permian, even the Siberia fused with the Pangaea. Okay, and you can see the supercontinent of Pangaea was complete. So very beautiful graphics you can see here. So talking about the paleoclimate, the temperature was 14 to 15 degrees Celsius, so pretty mild. You can say it was same as the present day temperature of the Earth, but the atmospheric oxygen was 35%, so pretty high. Climate of various land masses were controlled by their latitudinal position. Okay, so very basic English. You all understand that what it means. So bulk of Gondwana below 30 degrees south latitude, allowing continental glaciation. So bulk of Gondwana was below 30 degrees south, as you can see in this image. Okay, so this is the equator, this black line, and the bulk of Gondwana, so 30 degrees somewhere around here, and the bulk was here. So glaciation was there, extensive glaciation was there. Okay, and better areas in north started to form coal deposit. So as you can see, Carboniferous is famous for its coal deposit. So the wetter portion, that is in northern areas, the coal bearing forests started to form. Sorry about that. So that's it for today. In another video we will start about the life during the Carboniferous period and some very interesting fossils and animals that lived during the Carboniferous period, and also the evolution of the ammonoids. Okay, so that's it for today's video. Thank you. Please like, share and subscribe if you like this video. Thanks.